Chapter 1, Lesson 3, we will be discussing the power of a power property. The power of a power rule or property states that when you raise a power to a power, you're going to keep the base and simply multiply the exponents. So we have an example here of a to the third power raised again up to the second power with the exponents of 2. When this happens, all you have to do is simply multiply the two exponents together, keep your base, and you get a to the 6th power. To apply the power of a power rule, it can be done again with all types of numbers. It can be applied with just a whole number, fractions, decimals, variables, and variables combined with coefficients. So in example A here, we have the whole number of 2 to the 4th power raised to the 5th. So they use the power of a power property and multiply the 4 and the 5 together to get 2 to the 20th power. In example B, they give you a fraction. Remember, the fraction is put inside of parentheses to emphasize that the whole fraction is being raised to the 6th power, not just the numerator. 2/3 to the 6th power, then again raised to the 10th. Again, they keep the base of 2/3 and multiply the 6 and the 10, simplified to 2/3 to the 60th power. Here in example C, we have 7x squared. Again, the whole thing 7x is squared because they put it in parentheses, and then that raised to the 3rd power. Since 7x is in the parentheses, we keep it in parentheses and multiply the two exponents of 2 and 3. And when simplified, you get 7x to the 6th power. Now, example D here, we are just dealing with the variable of a negative p. Negative p to the 5th power raised again to the 4th power. We are simply multiplying our exponents. So you get 5 times 4 makes it negative p to the 20th power. Again, remember that because 20 is an even number, we can simplify that negative p into a positive because a negative times a negative equals a positive. Now let's actually do some examples here. Here we have 10 squared raised to the 3rd power. We are going to use the power of a power property and keep our base of 10 and multiply our two exponents of 2 times 3 to get 10 to the 6th power. Number 2, 1/4 to the 3rd power, then again raised to the 5th power. We are always going to use the power of a power property when raising it to a power twice. I'm going to keep my 1/3 in my parentheses and multiply my exponents of 1/3 to the power of 3 times 5, and that'll simplify to 1/3 to the 15th. For 2a to the 4th power, raised again to the 5th power, here in example 3, I will use the power of a power property, of course. I'm keeping 2a in parentheses because the entire expression is being raised to the 4th and the 5th power. So I multiply those two exponents, and 4 times 5 is 20. So simplified, I get 2a to the 20th power. Lastly, number 4, I'm dealing with a negative variable of k raised to the 6th power, then to the 3rd. So I'm going to use the power of a power property. So I have negative k. Oops, little error there, no big deal. Negative k to the 6 times the 3rd power, which becomes negative k to the 18th power. Because 18 is even, we can go even further and simplify that to now a positive k to the 18th power. When you're asked to simplify expressions using multiple rules, so everything that you've learned so far this chapter, the product of powers property, the quotient of powers property, and the power of a power property, you're always going to go in that specific order. You're going to always use the product of powers property first. Then you'll simplify. Then you will apply the power of powers property, and then simplify. And lastly, the quotient of powers property, and then simplify. So in this example here, example C, we have b to the third power times b to the fourth power here in parentheses. Then again, raised to the fourth power divided by 2p to the third power. So we're going to apply the product of powers property first because just like in order of operations, PEMDAS, anything in parentheses comes first. So b to the third power times b to the fourth, I'm simply keeping my variable of b, my base of b, and adding my exponents of 3 and 4 because that's the product of powers property. I'm keeping that exponent of 4 on the outside, and I haven't touched this 2b to the third power yet. So simplify, this becomes b to the seventh power. The 7 comes from adding that 3 and 4 to the fourth power divided by 2b to the third. So now I can apply the power of a power property by simply multiplying the exponents of 7 and 4 together. So b to the 7 times 4. Again, I have not touched this 2b to the third because I'm applying the quotient of powers property last. So 7 times 4 is 28. So I have b to the 28th power divided by 2b to the third power. They jump right into the quotient of powers property here and have b to the 28th minus the third, because again we are subtracting exponents with the quotient of powers property. The 2 is on the bottom of the fraction because if we would have written this step out initially like they had us do in the last example, it would have looked like this: b to the 28th over 2b to the third. So they jumped right into doing that subtraction in the numerator first. So 28 minus 3 is 25. So that's what you're left with on the top, b to the 25th power over 2, or it could also be written as 1/2 b to the 25th power. It means exactly the same thing. All right, let's do some example problems here. Here we have in number 9, 12 to the third power times 12 to the second power, all raised to the third power. I know because of following the order of operations that I am first going to apply the product of powers property. So that product of powers property tells me that I am going to do what's in my parentheses, keep my base of 12, and add my exponents of 3 and 2. And I'll keep that exponent of 3 on the outside. So I'm going to simplify that, and I'll have 12 to the 5th power inside of my parentheses, and the 3 is still on the outside. That is the simplified version after the first step. And now I will use the power of a power property. And that tells me I'm going to keep, again, my base of 12 and multiply my two exponents this time, 5 times 3. So 5 times 3 is 15. So simplified, that becomes 12 to the 15th power. Let's do it with an exponent or a variable in number 10, negative c to the 5th power times negative c raised to this, all raised to the second power. I'm going to add in my little 1 here for my second negative c so that I don't forget to apply that when I'm using my first step, the product of powers property. So first I'm going to have negative c and raise that to the 5 plus 1. And then all of that will be raised to the second power. So I have 5 plus 1, negative c to the 6th power, some double parentheses here, all raised to the 2nd power. That's simplified. And now I can again use the power of a power property. So negative c to the 6 times the 2 power, which becomes negative c to the 12th. And again, another example here where we can simplify that negative variable to a positive one, a positive c, because our exponent is an even number. All right, let's look at number 11 here. We're going to have to apply all 3 powers. Always, always, always first when applying, we are going to apply the product of powers to start. So I'm going to deal with what is in my parentheses here. X to the 1st power times x to the 3rd power. I'm going to keep my base of x and add my 1 plus 3. Keep that 2 on the outside, and I'm not touching that 3x squared yet. So that all simplifies down to x to the 4th power squared divided by 3x squared. Now I'll apply the power of a powers property. So I'll have x to the 4th times 2 divided by 3x squared, which simplifies down to x to the 8th divided by 3x squared. I'm going to write this down in the fraction version like I taught you in previous lessons off to the side. X to the 8th over 3x squared. So now I can I'll keep my x's on top, x to the 8th minus 2 over 3. I ran out of room. That's what would go on this line here. And we are using the quotient of powers property now because it was division and I'm subtracting my exponents. So that simplifies all the way down to x to the 6 over 3, or it could also be written as 1/3 x to the 6. Either would be accepted. And on this last slide with number 12, we have one more example problem, this time involving fractions. We are going to simplify using multiple expressions. First, as always, we are going to use the product of powers. First, so I am going to I'm going to write it up here where there's a little bit more room. I'm going to, on the top, have my 1/2 raised to the 2 plus 4. And all of that raised to the 3rd power. Still over 1/2 to the 2nd. So that simplifies to 1/2 to the 6th. Sorry for that little interruption, but as I was saying, that simplifies to 1/2 to the 6th power, all raised to the 3rd power, over 1/2 squared. So then we are 1/2 squared. What happened? Now we're going to use the power of a powers property. So I'll write that over here. This is what would go on this line if you want to have it in exactly the right spot. That's not exactly important to me as long as you know what you're doing. So on top we'll have 1/2 6 times 3. Again, the power of a power property says we can just multiply over 1/2 squared. I simplify that down just by multiplying my exponents, and I get 1/2 to the 18th power over 1/2 squared. And now I can apply the quotient of powers property. And I'm simply going to subtract my exponents. So I have 1/2 with 18 minus 2. Simplifies all the way down to what our final answer is, as 1/2 to the 16th power. And that's it. Again, remember, always apply in the order of product of powers property, power of a power property, and then quotient of a power property.